Hello, good afternoon. I hope you've had a great day at NE-RPC, and I think I'm the final person to speak today, and I'm going to be talking all about the BaaS in the words of Megan Trainor. So I guess a little bit of an introduction first. Who am I? I am, if I can click the next slide, I'm Mark Jones, Technical Principal at Scott Logic. I know it's horrible, it's probably the most ghastly thing I've ever created in Photoshop, and I'm going to really quickly just move on. What is BaaS, or I'm talking about BaaS or BaaS, or however you pronounce it. There's lots of these BaaS, SaaS, PaaS going about. BaaS is one of them ones where working for consultants like Scott Logic, where we do a lot of work in the investment banking world. Banking as a service is a thing, and BaaS is the abbreviation, obviously. Backup as a service has been a thing that's been around for a long time, and Backend as a service is what I'm actually going to talk about today. So, what is Backend as a service? It's pretty much Backend as a service was developed a while ago to actually get front-end developers up and running quickly. So if I'm an app developer, I don't really want to spend a lot of time setting up a back-end, building an API, doing all sorts of bits just to get my app to work. And there's a lot of them knocking about. You'll be familiar with some of them. I'm going to cover some of these today, but I'm really going to focus on a thing called Firebase. And anybody who's heard me talk before will know I'm quite enthusiastic about Firebase. I'll explain what it is in a bit for those of you who've not heard of Firebase. And I would like to talk today about why backend as a service type products like Firebase can actually get you up and running much quicker, and how in the past they've always been viewed as a Kickstarter, if you like, for digital agency type developers, so people who build apps and people who build a lot of front-end stuff. And what I'd like to talk about is how you can use this as a Kickstarter to get your entire solution built, so front to back end, and be used in large enterprise too. What's knocking about out there for enterprise? Well, these days in enterprises, they're all talking about the cloud, and let's face it, there's Alibaba and IBM, but generally it's normally AWS, Google Cloud Platform, GCP, or Microsoft Azure. And actually, if you went to a big enterprise vendor who want to move into the cloud, fine well they'd be looking at one of these three generally. They all have a different market share. Today I'm going to pretty much focus on GCP or Google Cloud Platform, and how do you get stuff into there. Anybody who's looked at any of the sort of the service offerings within AWS or within GCP or within Microsoft Azure, you'll be very familiar with that login screen that you sign in, and when you sign in you get a list of about 300,000 even of different products, and actually it's quite overwhelming. It's overwhelming to the point where organisations like Amazon for AWS have actually produced a bunch of certifications where you can go through and learn groups of these things and learn how to be a certified solutions architect or certified this, certified that. From a UI point of view, and like jokes, I've always said if something's so complicated that you need explaining, then it's not funny. And a lot of these user interfaces for these services are not funny. You will never find a cloud engineer generally, and I'm talking even sort of the cloud evangelists who work for these companies who know every product inside out. And actually, imagine you're an enterprise, a large enterprise who's done a lot of things on site or on-prem in the past, and actually now has moved or wants to move into the cloud. Your developers are going to look at this and they're going to go, hell no. There's just too much to learn if you've not done it before. So if I'm a front-end developer and I want a back-end, there's a bunch of offerings that came out not so long ago, and actually one of the first was Google's Firebase. And Google's Firebase, what it did was it said you need a bunch of things to build a front end that we will provide as a back end, and we'll make your life easy, and we'll give you SDKs, and we'll give you software and ways of doing that. The AWS then brought out a product called Amplify, and Microsoft's not really quite there yet. However, they have a thing called App Service. Move on. There we are. So Amplify for Amazon, Firebase for Google, and an app service. Not quite the same thing, but kind of in the same space. For Azure, some people who haven't seen Amplify for AWS might have come across a thing called Mobile Hub. I think Mobile Hub was the first incarnation of Amplify. And like pretty much most of the cloud vendors, it was a third-party product that was a really cool product that was bought in by the cloud provider, by AWS, and then rebranded to match something. I don't know. It happens all the time. These aren't the only backends as a service knocking about. These are the three offerings by the three big vendors. But there's been a lot of these things around for a while. Amplify's there, Firestore's there. We've got Serverless. Serverless is more of a platform as a service, but you can actually build bundles of platform services to give you a backend. I guess Heroku's been around for a while. They started out just hosting people's websites, amateur projects. And Back4App is probably one of the newer ones. It was an open source project, or started out as an open source project, and that now provides backing. So, I mean, if you think about what you really need when you're going to build a full stack, you need some stuff to build it with. And I've been building full stack software for a long time now, and it's always the same stuff. It's always the same stuff you need. So you pretty much want some storage, somewhere to store your files or data. There's some logic involved, and that's your business logic, and that's generally server side. I mean, given these four things I've got on here, this could all be a desktop application. You still need storage, you still need some logic, you need an API, you need some way for your logic to integrate with your UI. In some standard patterns, for example, MVVM, your view model, essentially the API. And then your UI, which is the bits on the screen, the buttons and the text boxes and the pictures and everything else that you see. These are the four building blocks, I guess, of building any real system. And we all know this; we've all done it. With the backend as a service, when backend as a service was conceived, it was conceived that people building UI would need the API, the logic, and the storage, and therefore it was a mechanism to provide those things in a very, very simple way. There's some other bits and bobs that generally come into building full stack applications. You need a transport generally. These days, most of your storage, your logic, and your API is separated from your UI by the internet, and you need some way of getting that data across the internet, or a network, or a LAN, or something. We don't generally build large desktop applications these days that live on desktops. I'm not saying we don't. We do sometimes. So applications such as highly intensive mathematical operations or video processing. The full Adobe suite is a perfect example. So Illustrator, Photoshop, you would never want to be doing that in the cloud. So you need some form of transport. You need some way of the data getting from the UI to the API. And actually, a lot of the time we take that for granted, especially with HTTP. It's pretty much there for you. If you write something in a browser, you've got the HTTP stack, which will get stuff from servers for you, as long as you stick to the bounds of what you can do with HTTP. Nearly every application you'll want some logging, and nearly every application you'll want some form of authentication. At least in the bottom three layers. Not so much on the storage, but you might have authentication on your storage. And I guess you want to know what your users are doing. So on the UI and the API, you probably want some analytics as well. So you want to know how often your APIs are being used or which button your users are clicking. And all of these things are things that actually you want to build a piece of software. So this translates directly into Firebase. Firebase was conceived to make your life easier in this space. So with Firebase, you have your storage. So you've got Firestore, which is a high availability real-time document database. You've got real-time database, which is the old real-time high availability database that preceded Firestore. These days, it's recommended that you use Firestore for new projects, but the real-time database still exists. And then you've got storage, with file storage. It gives you file storage with shared links in the cloud. And then your logic layer, you've got the options of App Engine or Cloud Functions. With Firebase, you don't really get direct access to App Engine. You can configure the default App Engine that's there running for you as part of Firebase hosting. But you can build Cloud Functions, which will give you logic. And actually, those event-based functions, which can trigger off Firestore and everything else, or basically your logic layer. And then we talked about the transport. So the transport, getting things to and from the web, is great, but there's lots and lots of work to be done on the HTTP layer all of the time. And actually the work that's to be done on the HTTP layer is normally repetitive work. There's libraries around like SignalR and all sorts of other stuff that will try and send data over WebSocket, and then if WebSocket fails, use long polling, and then HTTP2 is a new process, a new protocol now. So HTTP2 is available where servers can push information that's related information. And there's lots of these changing concepts, and you'll tend to do very, very repetitive work around this transport layer. And what you really want is just something that works, that somebody else is maintaining. Like I say, SignalR is a perfect example of that. Firebase actually gives you that in the Firebase SDK. And then the actual transport for Firebase is HTTPS or so secure HTTP or secure WebSocket. And then you get Firebase logging, you get Google authentication, and you get Firebase analytics out of the box with Firebase. So you've got all of the stuff, all of the building blocks that you actually need to build a front-end application, because they've given you them. So, we're a UI developer, or we're a full-stack developer. We're going to build a UI, and that UI is going to talk to a backend. What we've been given by Firebase is the ability to have all of the pieces we need to do the backend, and we can actually then focus on the front end. But even when you're building a front end, especially if you're building a web front end, and let's face it, that's what most of these front ends are these days. And that's what I'm going to focus on now. I'm going to focus on a single page application type front end. I'm going to focus on React for the benefit of this talk. Other frameworks are available. In fact, many. Normally a new one every week. So we're going to build a React app, and we're going to need to talk to a backend. And imagine we're going to do this in an enterprise environment. So this is not me just sitting at my desk tinkering with a UI. It's not a small sort of new startup. Imagine you went to one of the large investment banks and said, we're going to build a new UI. They would then have to sponsor a bunch of projects to actually make sure that the data that you need in your UI is available to you. So there would normally be some big project plan around this. There'd normally be a big program manager that would look after this. And what they would generally do is they go, right, well, we're going to do Agile, we're going to do Scrum, because everybody does Scrum these days, apparently. I'm told so. And we're going to do sprints. We're going to do 2-week sprints, and we need a backlog. And then they'll have to split that, because basically they need a backlog for the UI guys. They're going to need another team building you an API or building you a backend to actually serve that data. Because God forbid, as an enterprise, that they would actually get something off the shelf like Firebase, which gives you the backend and makes life easier. And actually, if you need something, a front-end developer can write it, because pretty much they're going to be writing in JavaScript or TypeScript, and the backend supports JavaScript or TypeScript. No, they'll have to employ a team of about 8 people using .NET or Java to write a full-blown API, and they'll write their own authentication, and they'll roll their own logging framework, and they'll roll their own this and their own that. And of course, what always happens then is they don't really know what they're going to build when the project starts, so everybody's invented this concept of Sprint Zero. So let's think about what we do in Sprint Zero generally. So Sprint Zero normally consists of a bunch of these things and a million other things. So there'll be lots and lots of chit-chat about CI/CD. There'll be developers frantically trying to get something that will deploy something that you haven't built yet into an environment that you don't know what exists yet, and in a way that you've never really formalized. There'll be a massive argument for about a week about code style rules, whether we should have 4 2 spaces or tabs, or the fact that if we're in JavaScript, whether we should have we should be using let, const, var, whatever. There'll be a week's argument about styling rules. There'll probably be about 300 different decisions about what the folder structure should look like. And at that point, then they'll actually get around to creating maybe a backlog of some things. And most of those things will be about to decide on what the code and style rules are, to decide on the CI/CD process, and decide on the project folder structure. Excuse me. That tends to be what happens. So you've done arguing about all of these different things, but actually, what should you really be doing in Sprint Zero? Should you really be frantically working on your CI/CD pipeline to deploy something that you don't even know what it is yet? Should you be arguing about code style rules? Should you be arguing about your project folder structure? Probably not, because at the end of this has all been done before. Someone's done it before. You'll have done it on a previous project. You'll have teammates who've done it on a previous project. And actually, lots of other companies have done it. For example, the people who built Firebase at Google, they've done it. And it's all done for you. So this is my point. So I guess if you didn't have to do CI/CD, and you didn't have to do code style rules, and you didn't have to argue about your folder structure, then what could you really do in Sprint Zero? Well, I mean, I guess the things you should be doing, right? You should be onboarding your team, so making sure everybody's got a development environment and can actually do some work, making sure everybody's got the credentials and need to log into your cloud platform, GCP, AWS, Azure, whatever, and actually creating a backlog of work, actually going through and talking about what you're actually going to build and speaking to your BA or your UX or your user research person to actually talk about what are the actual requirements for this application. Because the thing is, the tech should always be secondary. I think in a lot of the cases, doing the function of doing the tech becomes more important than actually building the application. And actually, if you think about what you really want to do, you really want to build your business logic, you want to build the application. The tech is just a tool. You wouldn't spend, I'm going to use a car analogy, anybody who's seen me speak before knows I use a lot of car analogies. But if I'm in the garage trying to fix the car, I want to fix the car. The reason I'm in the garage is to fix the car. I'm not in the garage to spend an hour messing about to get the right tool to fix the car. If I spend too long finding the right tool, I'll just use a hammer. I'll just hit it with a hammer. That's fine, because a hammer has worked in the past. And I guess this is the point I'm trying to make. Sprint Zero and rolling onto a new project should be about defining what it is you're going to do on the project. It shouldn't be about trying to take care of all of the stuff that you know is going to be a bind when you start working on the project. I'm a big believer in Agile with a lowercase a. I'm kind of a little bit bought into Agile with a large A. I don't think I've ever done it properly. I don't think anybody I've ever spoke to has ever done it properly. And actually, when you speak to people who do it regularly, they talk about the whole point of Agile is to find something that works for you. And it's in the words of, I think it's Captain Barbossa on Pirates of the Caribbean, they're more guidelines than rules. But I am a great believer in the concept of the skateboard, bike, car, bus, or t-shirt sizes, or whatever else it is that you use to describe them. I guess the point being is at the end of each sprint, or at the end of each phase, or at the end of each iteration, or whatever you call your iterations, you should have a fully functioning thing that works. It wouldn't make sense, for example, if we changed this round to in the first picture be the wheel, because the wheel you can't do anything with that. Having a skateboard, then a bike, and then a car, and then a bus makes a lot of sense. But if that's the case, what if you could just get the skateboard? What if Firebase was the skateboard? You're there, right? Because if you think about building your business logic for your very first sprint, you're probably going to want to do something really, really trivial to prove that it can be done, but it needs to be fully working at the end of the sprint. And what you don't want is the sprint where 80% of the work in that sprint is to get the thing that you've just built, tested, linted, and deployed. You want 80% of the work to be building the thing and 20% to be getting the thing deployed. So if you can get a bunch of tooling and stuff that's been done for you before and works and is well tested and well used, and say, right, we're just going to use that for now, then you can actually spend the majority of your time on actually building your application. So I'm going to draw a discrete veil over the fact that enterprises always like to have this enterprise scalable thing from day one. And I'm going to draw a discrete veil over the fact that everybody now is probably sitting thinking, well, this is all great, Mark, but I know where you're going with this. By the time you get done, we're going to have something built, but we're going to have to rebuild it for an enterprise because it won't be enterprise scalable. All I'm going to say for now is I'll come to that in a bit. But what I'd like to do now is, I guess, for anybody who's not used Firebase before, is give a little bit of an introduction to Firebase and just show some of the toolings that's there. So I don't know if you've noticed there's a bit of a theme been going on with my talk, in that it's very, very pink and fluffy. It's very, very all about the base type video oriented, and it's full of interesting facts about Megan Trainor. So we're going to build something. For those of you who don't really know Megan Trainor, I don't know Megan Trainor personally, but actually I think probably one of her most well-known and actually well-loved things that she ever did in all of her career, of course, was to be the voice of Smurf Melody in the Smurfs. So what I'm going to do is I'm going to build a Smurf database. Couldn't think of anything else to do, and it seemed sensible, and it's a bit of a light relief from the pink slides we've had. So as I said a few seconds ago, let's build something. By the magic of recording, that was actually yesterday, and the thing you didn't hear was actually all of the kids come running through the door and totally ruin my flow and everything else, and I was never getting the rest of this actually recorded. So it's actually tomorrow now in my world. It's a few seconds after I just spoke to you before. I'm going to say it again. Let's build something right now. So I'm going to switch over to VS Code. I use VS Code all of the time. Oh, that's not VS Code. Let me quickly minimize that. So in VS Code, I did say getting away from the pink slides, but this is my VS Code for this particular talk, so getting away from pink here. What I've actually done in here is I've created a Firebase reference project, and that involves downloading the Firebase tools, CLI, so the command line interface for Firebase, doing a Firebase init, and then I'm just answering the questions, and it'll ask you sorts of questions about which storage do you want to run linting, everything else, and you can do yes or no answers to that. That makes getting essentially your environment set up very, very easy. I'm not going to go through that now because this is not about setting it up. This is about introducing the tool, and it's so easy to use. It's not worth covering. But what you end up with is something a bit that looks like the folder structure on the left. In order to do that, you can tell Firebase tools to create you a project, or you can create a project yourself. I've created a project myself, and the reason being is, although Firebase tools is great, one thing it doesn't do is initialize your Firestore database, and if you try and tell it to use a Firestore database, it'll barf on that and say, no, you can't use a Firestore database because you haven't set it up yet. So basically, I went to the console, I created my project in here, and as you can see from the Firebase console compared to the Google Cloud console, it's a lot more front-end dev-friendly. It's very pretty. It's got lots of pointy, clicky stuff. Whereas obviously the Google Cloud console is like just lots and lots and lots of dashboards. And this is the point I was making earlier. When I say earlier, I mean yesterday, about it being a little bit overwhelming. So we've got a project. We've created our link to the project and created actual a boilerplate, if you like. And this goes back to what I was originally saying about your Sprint Zero, about all the arguments you have over linting and everything else. Well, what's happened here is Google's give us an opinionated view, and I kind of value Google's opinion. We're building something for their cloud. They've probably thought it through. They've probably got a few projects in there, I'd imagine. So I'm quite happy right now just to go with their opinionated view and not spend days and days arguing about it. So we've got linting rules, we've got a bunch of other stuff. Really, really quickly in here, we've got a functions folder, so our logic, all our cloud functions. We've got a public folder, so this is stuff that just gets published to your Firebase hosting. So essentially, this is run in App Engine, and it gives you a 404 page, pretty much for everything other than the root. And if you go to the root, it gives you a pretty index page with the Firebase logo that just says, "Sorry, there's nothing here right now, but this project's been set up by somebody." The usual stuff. You've got a few other things in here. You've got your Firebase RC file. All this does is just retain the link between this project in source to the project name in the cloud. You can ignore Firebase debug log from when I installed it, and then I guess probably the three most important files in here: Firestore rules, Firestore indexes, are to do with how you index your Firestore database, and access control. I'm going to cover Firebase JSON very, very quickly first. So Firebase JSON, pretty simple. It says this is the rules file, this is the index file. Before I do any deployment, I want to run linting, and you can set up lots and lots of hooks, what we call Git hooks, but they're not in Git, they're elsewhere. And then this is your hosting, so I'm going to say copy everything from the public folder. I'm going to ignore files in the public folder that follow this pattern, because obviously I don't want any node modules, that sort of stuff. So this is essentially a deploy ignore, if you like. Reasonably simple file, that's it. If I go and look at my function code here, I've got my linting rules for my functions. I've picked JavaScript. There's an option to pick TypeScript when you first set the project up, and that'll install the TypeScript compilation functions and everything for you. I've gone with JavaScript just because when you're doing this sort of online thing where you're talking about stuff, it's much easier to not worry about remembering what the types are. I know it's sloppy programming, and you would never do that in a prod world, but right now it kind of works. And you get a nice little example of an HTTPS function. So an HTTPS function essentially could be an HTTPS API, or any function that is triggered by you hitting an HTTPS endpoint. And then the endpoint will be represented when you deploy this function. So let's go back to the project. We were talking about having a Smurf database, and I guess I don't really want to talk about the code so much. I guess what I want to talk about is all the concepts I was alluding to earlier. In that actually, you've got two teams here when you're building a full stack thing, where you've got two pieces of work that need to be done in any large enterprise. You've got the guys building the UI, and you've got the guys providing the data to the UI through an API or a database or some other method. And actually, they're both very, very tight dependencies on each other. They're not decoupled in any way in most organizations, because basically the API team need to know what data the UI team need to display, and the UI team need to know what is available through the API. It's kind of a chicken and egg. What do I build first? Do I build an API providing the data I think the UI needs, or do I build the UI against some mock and then give that mock to the API team and let them then go and build the real API? Obviously, the problem with the first approach is fine well the API team is going to build an API that's not suitable for the UI team, because they'll find some use case or some story that the API doesn't cover. And likewise, if you do it the other way around, you spend your whole time building this UI against a mock thing, you never have the real thing, then you give that mock to the API team when you've got to a point where they can start building something. And at this point, the API team is then behind the UI team, and they're providing the UI team with something after they need it, so the UI team can't test against the real thing for a while. Sorry, I just knocked my drink over there, all over my laptop. That would not have went well. And what did I say? So the UI team would be developing against an API. You know what I mean. You've all been there. You've all done it. I'm going to move on. So, what do I really want to do? Well, the API team wants to probably kick off whenever they want to kick off, and the UI team want to kick off the project whenever they want to kick off. I'm going to put myself in the seat of the UI developer, and what I really want to do is I just want to build something. So I guess a good way to get started with React is create React app, and I'm just going to do that now. So in here I'm going to do I've already installed create React app as a global dependency. I'm going to create this in my reference folder. So I'm just going to minimize that. For now, I'm just going to use. I'm going to assume monorepo, and I'm going to have everything in this one folder, or I want this one repo, this one Git repo. So you probably notice a jump in the video there. I was doing lots of coding and showing how to do create React app, and that really took me over my 40 minutes. And I'm told by the NE-RPC team that I only got 40 minutes. Probably due to all my waffling in the first part of this talk. So skipped on a few stages, and actually what I've been doing is I've been just creating a few little bits of code I was going to walk you through. Like I mentioned, it's not a React tutorial, it's not a Firebase functions tutorial or an Express tutorial. It's more about the concepts involved. So I think where I left here, I was creating a React app. What I've done is I've created a React app which has one component currently, and what this is my Smurf app, and it allows me to grab some Smurfs and show them. Now I need a way of grabbing them, or I need somewhere to grab them from. And I mentioned before, we don't know whether the API team's built the API yet, so I just want to grab them from Firestore. So on the right hand side here, you can see I've created Firestore, I've created a Smurfs collection, and I've created Megan as Smurf Melody in that Smurfs collection. So I've got some data. I can very, very easily get that data from there using the Firebase API. What I have done is, though, I've abstracted that away into a service. So I've created this Smurf service, and this Smurf service initializes Firebase with the app key, which you can get from the Firebase dashboard. And then I have exported this list Smurfs function, which currently is going to list Smurfs from Firebase. And what that does is that grabs a bunch of stuff from the Smurfs collection, and then you've got to map it because you get a snapshot back. You don't get actual documents back. So let me show you what that app looks like. It's running here somewhere. There we go. So it's running. If I refresh it, so you can see there's a slight time delay. I don't know what it's like on the video there, but there's the app, and it's going off and it's getting them. I can add some Smurfs into this database, and let's do. Who else we're going to add? Who else? So Smurfette, I think. So Smurfette was the main female lead, I think. Oh, hang on. What am I doing? So that was a name and actor. We all remember, of course, that was Katy Perry. Can't spell Perry. Great, save that. But you see, my app hasn't updated or anything, and because this is essentially a fetch type thing. But I'm still getting it from the database, so if I refresh that now, it'll go off and get it, and we should get the both of them. That's great. It's all well and good. I can continue styling my lovely pink app and laying it out as a UI developer, regardless of what the UI team are the API team are doing. In the background, the API team's actually started building the API, and I can show you what it looks like. So we talked about functions. So we've got the Smurfs API, which basically registers a non-request with this API, and I've abstracted that API into another file. And then I've created a a/API/Smurfs endpoint, which does pretty much exactly the same code as you saw before. It initializes the app. I don't need to pass a config because this is going to run in the cloud project, so it knows its configuration information. And there's a few other little things I need to do. For example, I need to require things in because it's going to run a Node.js rather than import. And then because I'm running Node 8 in the cloud, I'm using I used the REST spread operator in the front-end JavaScript, but actually I need to use object assign in the back-end JavaScript. That's just the Node.js version. So this all works. I mean, the point I'm trying to make is now build an API, and then once they built the API, because I actually abstracted this away, I can then change my code very, very simply from grab from Firebase to grab from the API. I'm expecting the data in the same format because the guys who built the API have used my Firestore to do that. So let me just save that. What I can do is I can stop this running because the app is running currently in dev mode. I can do an npm run build. That'll be quite quick, hopefully. And if you've used create React app before, you'll know that React scripts puts it in this build folder. Then through some very, very clever mapping in Firebase JSON, I can say the target for the Smurfs app is the public Smurfs app build folder. That's all it needs to know. And then I can. The other thing I've then done is ask for some rewrites on hosting. So anything it doesn't know about will rewrite to index.html, which is great because it's a single page app. And anything that comes to /API, any document, maps to the Smurfs API endpoint, which is the cloud function we've just created in the API, which should work, which is great. So now if I go to this and just do Firebase serve. Oh, hang on, Firebase serve with an E. This is going to run up local emulators to emulate Firebase. However, because I haven't run up the Firestore emulator locally, it will use the cloud Firestore, and it'll warn me about that. But you can see now it's mapped a bunch of stuff. So I now have this localhost 5000. So if I go back to my app and change this to 5000, and then before I click enter, let me just go to the network tab. You should see that this time it'll hit the Smurfs. So it's hit the Smurfs endpoint, which is my API. So that's the API, and it's pulled the same data from the Smurfs endpoint. So I've been able to build my app, work on my front end independently of the API team. Where was I going with that? Well, let's go back to my slides. Slides are here. Cool. So we've now got to a point where we've got the UI team working there, the API team working there, and they can work independently. And as long as you abstract away the interfaces or the API part, the communication part, or transport in my original slide, then you can essentially work independently of each other. And actually, one team can actually define things. There's a school of thought that says that you should actually define data contracts really, really early on, and the API team and the user team should spend weeks and weeks and weeks of planning in a room to work out exactly what the API looks like. It never really works in principle. You end up almost becoming your own sort of standards body, where you end up in months and months of meetings trying to decide whether a parameter should be sent as a number, or whether it should be sent as a string, whether it should be what sort of JSON you should use. It's just horrendous. Whereas actually, if you both teams work independently, but in the same environment, then you can compare and contrast. You say, well, actually, I need that field, or well, we can't give you that field, we can give you this field, and you can collaboratively work. It's a much more collaborative approach with two separate independent teams, but working very, very closely. And there's no reason why in the future you shouldn't formalize that, and actually you definitely should formalize those contracts. So all of this stuff I'm creating is essentially Firebase is a window into GCP, and therefore all of the stuff I'm creating actually is in GCP. So should I use GCP? Should I use Firebase? Well, use both, because Firebase is the kickstarter to getting things into GCP in my mind. And in GCP, all of the services map, so go back to my original slide about storage. You've got Firestore Cloud Storage is your storage, which is pretty much the same as Firebase. You've got Cloud Functions and App Engine, same as Firebase. Firestore SDK, I continue to use the Firebase SDK actually. Firebase wraps up Firestore and a few other bits and bobs. In fact, actually it doesn't. It wraps up gRPC and a few other bits and bobs, but let's not go into the details or semantics. You've got logging is Stackdriver, and actually Stackdriver has since become lots of different products. It's no longer just Stackdriver. It's lots of other bits and bobs. And then Google Authentication and Google Analytics, so all of the extra bits that you'd expect from Google. This is my last slide, and I really want to wrap this up. But before I wrap this up, I really, really want to quickly show you something. So we talked about building your app against Firebase initially, and then have the API team build the API against the database. But obviously, we all know RESTful APIs to and from, request response type APIs, or a piece that's they're not as modern. A lot of new apps need data now, and they want push style data. And the obvious way to do that with a live online app is through WebSocket. And actually, I mentioned right at the very start of this talk about maybe using SignalR or some transport or some SDK that's been built for you. When we were originally doing the fetch from direct from Firestore in a permissioned way and not using the API, the API that we built, then we were getting data once, and then we'd have to request. That's still the polling request response type pattern. Let me show you one last quick thing. If I go to my Smurf service, you see I created this other thing down here called subscribe to Smurfs, and actually, so this uses the onSnapshot method rather than the get method like I did when I was getting from Firebase. So if I go back to my app and in my component, you'll see I might have been prepared to do this. In fact, I was prepared to do this. If I comment out the effect that actually gets a list, I get the list of Smurfs once when the component mounts, and do this, which subscribes to Smurfs, then I should be able to. And I'm actually just going to shut this down because we're not using the API anymore. I can actually just run this locally, so I can do npm start and just run this in dev mode. Go back here and do 3000. We're already there. Cool. So because I'm now subscribed, under the hood, what Firebase SDK has done there, it's essentially created a WebSocket connection to Firestore for me directly. So if we can think of some more Smurfs, I can switch back to my demo, because you didn't see what I just typed there because I was on the wrong screen. Sorry about that. But basically what I did there was just start my app back up in dev mode. I can go and add a document in here, so create another ID. Let's create another Smurf. If we were in public, I could probably ask you to name Smurfs, and everybody would come up with Papa Smurf because it's the one that everybody knows. But does everybody know who played Papa Smurf? in the actual film. Who was it? I can't remember who it was who played Papa Smith. That might be a question for the end. I might look it up, and then if you want to ask me some questions later, I'll just do anon. There we go. Jonathan, something, I can't remember who it was now. Anyway, so someone who played Papa Smith, and you saw when I had Papa Smith there, he's instantly just appeared in the app on the left. And I can, likewise, because I haven't got his name in there, I don't like it, I can delete that. Remove the document, and you see that the app on the left is actually keeping itself up to date, and that's functionality that's in Firebase. It's part of the API layer given to you by Firebase. So I guess my argument would be here, when the API that's being given to you by the SDK that you've chosen and the technology choice you've made, why would you build your own? There seems to be this inherent drive for big enterprises to build their own APIs. Yes, you could build your own API to sit alongside of it, and you could use that API to provide data in an open API way to your clients and your customers if you wanted. But for your own apps, where you control the environment and you control the hosting of those things, and you control the intercommunication between your different component parts of your system, why would you choose to build an API that is inferior to the API that you get with the technology out of the box? And I guess this is the point of this whole talk. Backend as a service has evolved. Backend as a service was there to give you the necessary components to build something that works very, very quickly. Unless you can build something yourself that's better than what you've been given, why would you do it yourself? And actually just trying to get into that mindset of it's okay to reuse things is where I'm going with all of this. I'm sure there'll be questions. I'm going to try and wrap this up a little bit now. But I'm going to go back to my point. If you have the skateboard, bike, car, bus type analogy, when you've got something that gets you pretty much to bike, you just need to bolt the wheels on. Why wouldn't you take that option? Why would you do it yourself? I hope there's some questions. I'll be joining in the online chat at the end of this video when it's played. I've ruined the illusion. I've recorded this, so I'll speak to you soon in the chat, and I hope you've enjoyed it, and we'll catch up then. Thanks, everybody.